Right now, meteorologists across multiple states are still trying to officially verify hailstones large enough to rewrite state record books, and nearly every one of them fell out of the sky at the exact moment a major heat wave was collapsing, not during some unrelated winter storm season. In Connecticut, baseball-sized hail that fell during this summer's 4th of July storms may have broken a state record that had stood since 1969. In Illinois, a storm chaser measured a hailstone 6.5 inches across, larger than the state's official record, with craters left behind in the ground where it landed. In Texas, a 7.1-inch hailstone has already been confirmed as a new all-time state record. None of these happened in isolation, and none of them happened during ordinary spring severe weather season. Every one of them fell in the hours right after a dangerous heat wave finally broke, when the same explosive atmospheric energy that had spent days baking the region suddenly found somewhere to go. This is the story of why heat wave collapses keep producing hail nobody predicted, what the actual science says is driving it, and which of this year's records have already been confirmed versus which ones are still sitting in a freezer waiting on official verification. No hype, no exaggeration, just what actually happened and what the data behind it means. Drop a comment and tell me if hail like this has ever hit where you live, because I read every one of these. If you want grounded weather coverage instead of panic headlines, subscribe. It is free. And a like helps this reach people who need to understand this before the next collapse happens. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. The clearest example of this pattern happened on the 4th of July, right as the first major heat dome of the summer was finally breaking down across the eastern United States. A complex of storms moved through the southern half of southern New England that day, and behind an initial line of supercell-like storms came a strong line packing damaging winds and unusually large hail. National Weather Service meteorologist Bryce Williams described it as a series of storms that produced quite a bit of wind damage in addition to some large hail, with wind speeds generally estimated between 50 and 65 miles per hour. Reports came in of hail up to 3 inches in diameter, roughly the size of a baseball, in the towns of Bristol, Plainville, and New Britain, alongside additional reports of hail around 1.25 inches. The storms knocked out power to more than 100,000 customers across the state, with crews brought in from Massachusetts, New Hampshire, and Canada to help restore service. According to National Oceanic and Atmospheric Administration records, the officially recorded before that weekend measured 2 3/4 inches, first set during a 1969 storm and matched again in 1995. Williams said his team could not find any reports of 3-inch hail anywhere in Connecticut's records, meaning this event had the potential to be one of the biggest hailstorms ever recorded in the state's history. Gary Lesor, chief meteorologist at Western Connecticut State University, pointed out what made this particular event unusual was not just the hail size, but the size of the area it covered. 2 wide bands moving diagonally across the entire state from northwest to southeast, rather than the more typical pattern of a single county getting hit before the storms dissipate. Lesser explained the reason those storms held together instead of weakening as they usually would heading into evening was that there was so much heat and so much humidity still sitting in the atmosphere from the heat wave itself that the storm simply kept feeding on it, meaning the same extreme heat that had been punishing the region for days directly supplied the energy behind the record-breaking hail that followed it. That same basic pattern has shown up repeatedly across the country this year, not just in Connecticut. Storm chaser and AccuWeather meteorologist Tony Laubach measured a hailstone 5.25 inches in diameter in Kankakee, Illinois, larger than the state's existing record of 4 3/4 inches set back in 2015 near Manuka, describing it as some of the biggest hail he had seen in quite some time, with the ground left covered in stones and visible craters where the larger ones had struck. Other spotters in the same outbreak measured stones as large as 6.4 inches nearby. Physics professor and hail researcher Victor Gansini of Northern Illinois University later measured and submitted a hailstone from the same general region at 6.6 inches across to NOAA's State Climate Extremes Committee, the body responsible for making these records official. That same storm system also produced hailstones of 4.5 inches in diameter across parts of Texas and Missouri, stretching in an intense line nearly from Mexico to Canada. Separately, a 7.1-inch hailstone found in Texas has already completed the verification process and been confirmed as that state's new all-time record, a size in the same general range as the largest hailstone ever officially certified in United States history, an 8-inch stone that fell near Vivian, South Dakota back in 2010 and weighed nearly 2 pounds. It is worth being honest about how the official verification process actually works because it explains why some of these records take so long to confirm and why you should not assume every viral photo represents a certified record. Once a hailstone large enough to potentially set a record is found, it typically has to be preserved at full size in a freezer until it can be formally weighed, measured, and photographed by NOAA's State Climate Extremes Committee, and a state climatologist has to independently verify those measurements before anything becomes official. That process alone can take months, and in some cases years, which is exactly why meteorologists were still describing the Connecticut stone as a likely record rather than a confirmed one, and why the Illinois submission from Gensini was still working its way through NOAA's verification process at the time it was reported. Now let us get into why this keeps happening. Specifically, at the moment, a heat wave breaks. Because this is not a coincidence, it is basic atmospheric physics, and meteorologists have documented the exact mechanism in real time during comparable events. The measurement that matters most here is called convective available potential energy, or CAPE, essentially a measurement of how much fuel is available to power a thunderstorm's updraft, the column of rising air inside a storm that determines how large a hailstone can grow before it becomes too heavy to stay aloft and falls to the ground. A comparable event studied in detail by the National Weather Service, a severe weather outbreak that hit the Carolinas during an ongoing heat wave, showed exactly how this comes together. Ground level temperatures had been sitting near 100 degrees for days, while a pocket of unusually cold air moved in 3 to 6 miles above the surface. That combination, extreme heat, trapped at the surface with cold air. Arriving aloft created what meteorologists call steep lapse rates, meaning the temperature dropped unusually fast with altitude, and produced CAPE values between 5,000 and 6,000 joules per kilogram, a level meteorologists specifically flagged as exceptionally large and rarely observed. Feeding on that instability, the storms that formed developed strong, very deep updrafts capable of lofting hailstones, repeatedly through the layer of the atmosphere where ice accretes, adding another shell of ice with each pass, before the stone finally grew too heavy for the updraft to support and fell to the ground. That is the same basic mechanism. Researchers Yuzu Lin and Matthew Cumgen at Pennsylvania State University have documented directly, finding that environments with larger CAPE are consistently associated with storms capable of producing larger hail, and that storm mode matters too, with supercell storms, the same rotating, long-lived storm type described in both the Connecticut and Illinois events, consistently producing the largest hailstones observed. This is also precisely why heatwave collapses are such reliable hail producers. A multi-day heat dome does not just make the air hot. It lets that heat and humidity build and build at the surface with nowhere to go. Pattern responsible for the heat is also preventing fronts from moving through to release it. When a cold front finally does punch through and break the heat dome, it often arrives aloft well before it fully clears out the extreme heat and humidity still pooled at the surface. And that exact mismatch, dangerously hot, moisture-loaded air at ground level meeting, genuinely cold air arriving several miles up, is what produces the steep lapse rates and extreme CAPE values capable of building baseball-sized and softball-sized hail. In plain terms, the very same energy that made a heat wave dangerous for days is the energy that gets released explosively and often violently the moment that heat wave finally ends. It is also worth being careful and precise about how this connects to the wider pattern of large hail this year, rather than overstating it. Meteorologists tracking severe weather. Reports have noted that Colorado has recorded the highest number of large hail reports of any state so far this summer, consistent with the state's typical early summer pattern along the Front Range of the Rockies. A reminder that not every large hail event this year is tied directly to a heat dome collapse specifically. Some of it is simply the normal seasonal pattern playing out as it usually does. At the same time, research published through AccuWeather has found that both 2023 and 2024 set new records for the number of 2-inch or larger hail reports recorded nationally in a single year, part of a broader increase meteorologists and researchers have been tracking over the past several years. But that same research has also been careful not to oversimplify the climate connection, since the scientific hypothesis that rising temperatures should straightforwardly produce more or larger hail because warming affects multiple ingredients in the hail formation process at once, some of which favor bigger hail and some of which work against it. The honest scientific position, in other words, is that this year's specific pattern, dramatic hail immediately following major heat dome collapses in Connecticut and across the Mississippi Valley, is well documented and mechanistically well understood in each individual case. Even though the longer-term question of whether hail overall is getting bigger because of a warming climate remains a genuinely open, actively researched question rather than a settled one. So what does this actually mean for you, particularly if you live anywhere that has recently come out of, or is currently sitting under, an extended heat wave? It means the moment a heat wave you have been tracking finally shows signs of breaking is not necessarily the moment to relax. It is often the moment the atmosphere is primed to produce its most violent weather of the entire event. since all of the heat and humidity that built up over the preceding days has to go somewhere once a front finally moves through. And hail large enough to total a car or shatter a roof is one of the more common ways that energy gets released. It means paying attention to severe thunderstorm watches and warnings, specifically in the hours right after a heat wave breaks, rather than assuming the danger has already passed once temperatures start to drop. And if you do find hail large enough that it might be a record, meteorologists' advice is straightforward. Photograph it immediately for scale, using a coin or a tape measure, and get it into a freezer as quickly as possible, since an unpreserved hailstone will simply melt before anyone can verify it. The honest, grounded summary is this. Connecticut's 4th of July storms, which broke the summer's first major eastern heat wave, produced hail up to 3 inches in diameter that may break a state record that had stood since 1969, fed directly by the extreme heat and humidity the storms tapped into as that heat wave collapsed. Separate storms across Illinois, Missouri, and Texas this year produced hailstones as large as 6.5 and 7.1 inches, with the Texas stone already confirmed as a new state record. The mechanism behind all of it is well documented. Extreme heat and humidity trapped at the surface by a blocked weather pattern, met by genuinely cold air finally, arriving aloft as that pattern breaks, producing the kind of steep lapse rates and extreme instability that let hailstones cycle repeatedly through a storm's updraft before finally falling. Whether this specific pattern is becoming more common because of a warming climate remains a genuinely open scientific question, one researchers are still actively studying rather than one that has already been settled. We are going to keep tracking this as severe weather season continues, sourced the same way we did today, straight from the National Weather Service, NOAA's State Climate Extremes Committee, and the meteorologists and researchers actually studying these storms, not recycled headlines. Subscribe so you do not miss the next one forming, because based on everything we just walked through, the next heat wave to break is very likely to bring exactly this kind of violent weather along with it. And leave that comment below. Tell me if hail like this has ever hit near you and how big it was. Because behind every one of these numbers is a homeowner in New Britain, Connecticut sweeping baseball-sized ice off a driveway the morning after the 4th of July, a storm chaser in Kankakee, Illinois standing over craters a 6-inch hailstone left in the dirt, and a state climatologist somewhere right now, carefully weighing a stone pulled out of someone's freezer, deciding whether the record books need to be rewritten. 5,000 likes on this one. Let us go. See you in the next one.